in this video, we want to find the limit as x approaches 1 of x minus the fourth root of x over x minus 1. So I'm not going to be using L'Hopital's rule for this, and instead I'm going to be multiplying the top and the bottom. So the way to think about this problem is the difference of two squares. So let's start with this. Let's start with a squared minus b squared. That's a minus b times a plus b. So let's say x minus the fourth root of x was a minus b. That means a plus b would be x plus fourth root of x, which would be x squared minus the square root of x. And now let's multiply by the conjugate of x squared minus square root of x. So we have x squared minus square root of x times x squared plus square root of x. This will just be this x to the fourth minus x. And now this is no longer, we no longer have the fourth root of x here. So this is our thought process. So this is what we started with right here. And then we multiplied it by x plus fourth root x, and then x squared plus root x. So that's what we need to multiply the top and the bottom. So like we showed, the top, if you follow this, is equal to x to the fourth minus x, and then the bottom we have x minus 1 factored, and then I'm not going to bother distributing this. It doesn't make sense. It's too much work. So we can get away without doing that. And then at the top, we're going to factor this further. We can factor on x, and then we have x cubed minus 1. And then x cubed minus 1 can get factored further as x minus 1 times x squared plus x plus 1. And now the x minus 1s are going to cancel. So that gives us x times x squared plus x plus 1 over x plus fourth root of x times x squared plus square root of x. Now we didn't have to rewrite it, we could have just plugged it in here, but whatever, I just rewrote it. So we have 1 times 1 squared plus 1 is 3 over 1 plus fourth root of x is 2, and then 1 squared plus square root of 1 is also 2. So this is just 3/4 as our limit.